Electric vehicles continue to enjoy a rapid uptick in acceptance, but they have a glaring drawback: the battery. While the battery is crucial to the operation of an electric car, it is also holding it back in many aspects. However, a new breakthrough is about to solve the issues current EVs have with the battery and help Elon Musk achieve a long-range electric car. What does the Sulfur battery, the new battery, offer? How does the Sulfur battery manage to offer 900 miles per charge? Join us as we explore the all-new 900-mile Sulfur battery that changes everything. Elon Musk is bullish about battery-powered cars. Thanks to his long-term vision, grit, and ingenuity, he has built a monster company that is on track to make 1.5 million electric cars this year alone. Each of these cars has a battery, which happens to be their weak point. This is why battery research never stops, as we haven't even neared peak battery performance yet. As such, a new battery is in town that blows everything before it out of the water. This is the Sulfur battery, and it promises incredible performances. But before we look at the company behind the new Sulfur battery, what battery problems does Musk's Tesla have to solve? The first one is the cost. Musk has always wanted to make a $25,000 car that would accelerate the adoption of electric vehicles. However, he has not been able to reach that price point. Even the Model 3 that started around the $35,000 mark has now jumped by about $10,000. The biggest culprit is the battery, which is the most expensive single component. Thanks to the battery, the powertrain accounts for about half the cost of an electric car. But why are EV batteries so expensive? It's largely because of what goes in them. An EV uses the same rechargeable lithium-ion batteries that are in your laptop or mobile phone. They are just much bigger. The priciest component in each battery cell is the cathode. The materials needed in cathodes to pack in more energy are often expensive. Metals including cobalt, nickel, lithium, and manganese. They need to be mined and processed into high-purity chemical compounds. So, what prices are we talking about? Tesla doesn't reveal the cost of its batteries, but using current rates and pack sizes, the average battery cost for a typical EV works out to about $6,300. However, Tesla car batteries will cost much more per car because they often offer the longest ranges in the industry. It is true that battery pack prices have come down a lot, in fact, by 89% over the past decade, according to Bloomberg NEF. But the industry average price of $137 for a kilowatt of power for an hour is still above the $100 threshold that an EV's cost could match a car with an internal combustion engine. To worsen matters, costs aren't falling as quickly as Musk hopes, and raw materials prices have been climbing. The other battery problem Tesla is trying to solve is battery weight. Tesla cars weigh significantly more than comparable internal combustion engine models, and the accusing finger points at the battery again. For instance, the standard Model 3 comes with a 50 kilowatt-hour battery, and the long-range version comes with a 75 kilowatt-hour long-range battery. The standard Model 3 battery weighs 478 kilograms, while the long range weighs even more at 530 kilograms, and that is after the many improvements the company has made to its battery. The battery weight problem is a huge deal for Tesla, who will soon start delivering the semi-truck. The truck must be able to travel long distances, like cross-country delivery, while pulling up to 40,000 tons. A 900 miles range, for instance, will let the Tesla truck compete well with the diesel-powered big rigs. If the semi-truck is to succeed, Musk has to find a solution to both the cost and weight problems of EV batteries. This is where the Sulfur battery comes in. This new battery, in one fell swoop, will fix the two battery problems Tesla has and usher in a new age of electric cars. Tesla can easily meet up with a 900-mile range truck. Berlin-based Futureunity is a developer of lithium-sulfur cathode technology. The company has now appointed Dr. Ulrich Amers as CEO. Amers is coming in to lead the upcoming commercial effort of its crystal battery. Dr. Amers has a long track record of industrializing battery production at companies such as Leclanche. He also serves on the board of major battery research clusters funded by the German Ministry of Research and Education and is a member of European and German battery associations. Amers will bring the experience to the fore by helping Futureunity commercialize its innovative lithium-sulfur cathode technology. The new Sulfur battery targets triple the range and usage time compared to conventional lithium-ion cells. Futureunity operates 3 locations within Berlin, specializing in cell design, prototyping, and testing. Thion is expanding by adding manufacturing facilities to accelerate its mass production roadmap beginning in Berlin. Locations for later gigafactories will soon be determined. They will be located close to the customers, that is, EV makers. As such, the company will likely set up production plants in Europe, Asia, and the US. Thion's patented production process combines Sulfur's crystal material properties with carbon nanotubes and a proprietary solid electrolyte. Thion grows a pure sulfur wafer by a direct crystal imprinting method with no slurry coating, no solvents, no water, and no drying, directly from molten sulfur in a few seconds. Because of the flexibility of the process, the company can grow any geometrical shape of wafer adapted to a customer's product shape. Thion suggests a hexagonal shape for space efficiency reasons. Thion removes nearly all volumetric fluctuation of sulfur at the wafer level by a special conversion process. The cathode can work at low porosity. By adding conductive paths, the company maximizes the use of the active material to achieve a high energy density. A proprietary solid-state polymer electrolyte operates in the voids of the sulfur wafer. In Gen 1 and Gen 2 crystal cells, Thion will use lithium metal foil as anodes. The battery technology is compatible with a bipolar cell arrangement to maximize energy and power content. The cell stack is then assembled into a housing that geometrically best fits the customer's application to maximize modular pack system energy content. But why is Thion going with sulfur instead of other materials? The company says that sulfur is about 99% cheaper to source than cathode materials. It is often produced as a byproduct of several industrial processes anyway. This makes it far more abundant than any rare earth material used presently in battery manufacturing worldwide. In other words, sulfur is cheap. A single charge can be enough to take a car to run 900 miles, which is impossible with the lithium-ion cells in the present day. The battery cost and weight would have been prohibitive. Ames explained existing battery technology uses nickel, manganese, and cobalt for the cathode. It is called NMC811 because it has 80% nickel, 10% cobalt, and 10% manganese. He said in Thion's case, they swapped this NMC811 with sulfur, so there is no nickel, manganese, or cobalt. Thion also replaced the current collective folds of copper and aluminium with graphene, a special material. Thion's lithium-sulfur battery targets a gravimetric energy density of greater than 1,000 watt-hours per kilogram, a volumetric energy density of 1,500 watt-hours per liter, and a power capability of about 12,000 watts per kilogram. The new battery will survive cycles of about 1,000 at an operational temperature range of between minus 20 degrees Celsius and 60 degrees Celsius. Since lithium-sulfur batteries offer 3 times more energy capacity than conventional lithium-ion batteries for the same weight, it means Tesla's higher-performance vehicles can significantly increase their driving ranges. For example, the Cybertruck is promised to offer 500 miles, but what if Tesla uses Thion's battery? That will yield more than 1,000 miles, and Tesla doesn't have to worry about the cost because it will actually come down. Similarly, the Model 3 long range will have close to 1,000 miles between charges if Tesla doesn't change anything about the car's weight while using a sulfur battery. Tesla is also prepping the new generation Roadster, offering more than 600 miles. It is just a small leap for the company to deliver more than 900 miles of driving range while still cutting the weight. However, the best candidate for the sulfur battery among Tesla's future lineup is the semi-truck. Currently, even Musk admits the truck is ideal for shorter hauls along fixed routes. For example, Tesla is testing the trucks on runs between the Fremont and Nevada factories, a stretch of about 400 miles and about 11 hours of driving. The Semi can significantly step up its range using sulfur batteries, which can push the range into the 1,000 miles territory. Tesla will even be able to reduce the weight significantly, which will affect braking, loading capacity, handling, and more. Let's hear what you think of the new sulfur battery in the comments section below.